All right, so we are going to talk about finding probabilities when our information is given to us in the form of a table. So we're looking at information about passengers who were aboard the Titanic. My first question here is finding the probability that if I picked a random person, it is a male. So I'm going to look at my men column here, and I'm just looking for men in general. Now, they did break this down by survivors and non-survivors, but again, I'm just looking for men in general, not worried about their survival status. So the probability that I selected a man, there were 816 men aboard the Titanic out of the total 1,324 people who were aboard the Titanic. That would be my probability for my first question. For my second one, the probability that I pick somebody who survived. So I look at my survived row and I see that even though it's broken down by men and then women and children together, I just want to know just the total number of survivors, and I'm not worried about their gender or even if they were a child. And so I'm looking at 492 survived out of 1,324 people who were aboard the Titanic. And so that would be my probability that I picked somebody who survived on the Titanic. Now, my next question here, this one, we have this fun word in the middle that is going to cause us to have to do a little bit more work. And so if you remember the addition rule, we have the probability of A or B. And so when we have the word or between two events, we have to do the addition rule. And so that is when we are going to find our two separate probabilities. So the probability of A plus the probability of B. But if we take a look here and we see that we've got first our men, and second, we have survived. When we take a look at those two things, what you may notice, hopefully, is this 138 got highlighted twice. And what that means is that it actually would have gotten, or does get counted twice. And that highlighted 138, that double highlighted section, it actually represents the men and survived. And because it's counted twice, I need to take out one part of them. And so really what I'm subtracting is the probability of A and B. And so that and is the people who fell into both categories. And so when I do the math over here, let me change my color out. So first I'm going to find the probability that it was a man, which I actually have in number 1, 816 out of 1324. Then I am going to add it to the probability that they survived, which we actually found in question number 2. But again, I need to get rid of the 138 that were counted twice. They are not twice as important. They're not twice as likely to get picked. And therefore, I need to take away one set of them. So the 138 men who survived need to be subtracted. And now, lucky for us, when we do this math, we have common denominators in our fractions. So we are going to keep the bottom. And then along the top, we are going to add 816 plus 494, or 492, excuse me, and we're going to subtract that 138 for a total of 1170. Again, out of the total of 1324. Now our last question here, what is the probability that we select somebody who is a woman or a woman and child and also died? So they need to actually fit in both of those categories. And because of this word this and means they must fit both characteristics. So I'm really looking at the women and children. So this first column here for women and children. And I'm also comparing that to, and so with the died part here highlighted, I'm looking for that overlap. And so that is going to be 154 out of 1324 right